Hi, welcome to Math 1400, Nunez Community College. This section today is section 1.6. This is the graphs of the different types of functions. So today, the first thing we're going to talk about is the graph of the tangent function. Again, we're going to take the tangent, or we're going to take the unit circle, and we're going to lay the graph out on a linear graph. So we're looking at y equals the tangent of x. We use y and x because we're talking about a linear graph where we're talking about the x-axis. So if we look at it, we have to look at the tangent as being what? Y over x. So if we look at 0, y over x would be 0. So we have a point on the axis, which is at the origin. If we look at going up to pi over 2, we would have that tangent is 1 over 0. And we know that 1 over 0 is undefined. So at pi over 2, the tangent function is undefined. And as we come the other way, we come to 3 pi over 2 or negative pi over 2 if we're looking at the negative angle. And again, we would have y over x, which would be negative 1 over 2, which would be undefined. So we'll put this as negative pi over 2. So we know that at 0, the tangent function value is 0. We know at pi over 2 and negative pi over 2, it does not exist. If the function does not exist, this is called an asymptote. And we label it with a dotted line. An asymptote is a line that the graph never crosses. A line that the graph never crosses. So we also have the amplitudes of the tangent, which is going to be at 1 and negative 1. And the amplitudes will occur at what we call a halfway point, halfway or a quarter point, which is halfway between the first asymptote and the 0, and the 3/4 point, which is between the 0 and the right asymptote. Now, if we look at this here, this in between would be pi over 4. And the pi over 4 ordered pair, square root of 2 over 2 and square root of 2 over 2. Therefore, if it's y over x, square root of 2 over 2 over square root of 2 would be 1. So at pi over 4, our tangent function would be 1, which happens to be the amplitude here. And at negative pi over 4, down here, negative pi over 4, we have what? Square root of 2 over 2 and negative square root of 2 over 2. If we do y over x, that becomes negative 1. So at our quarter point, which is negative pi over 4, we're at negative 1. So again, we have our amplitudes, our asymptotes, which is where the line or the graph never crosses. We have our quarter point, which is a quarter of the way across, and that would be our negative 1, which is our negative amplitude. At 0, it would be 0, and at pi over 4, we would be at 1. The actual tangent graph would be connecting up the dots, and we put arrows because it keeps approaching this line, but it never actually crosses it. This is the graph of the standard tangent function. So it rises from left to right. We have amplitudes lower and upper, where the lower is on the left and the upper is on the right. The 0 is in between the two asymptotes, and this is what we have for our tangent function. If we look at the period of the tangent function, from negative pi over 2 to pi over 2 is pi units. So the period is going to be pi for the tangent function, and this is what it looks like. This happens to be 1 cycle. After this, it starts again, and it would come to another asymptote, which in this case would be what? It would come back around and would be 3 pi over 2. And it would be 1 more cycle. And it would look like exactly the same, where this being in the middle, the quarter point, and the 3/4 point. And with another cycle, we would have the same thing again. So the tangent keeps repeating over and over and over. This happens to be the tangent that we're looking for, and this is what the tangent function looks like if there are no other numbers that are on the tangent graph. Now, how can we manipulate that? Well, because of what we have here, the actual tangent equation, is going to be y equals a sine of bx minus c. Y equals a sine of bx minus c. A is going to be the amplitude, and that is the absolute value of A. The amplitude is going to say how high up and how far down is our quarter points and our 3/4 points. So if A would have been 2, it would have been at 2 where it crossed, and it would have been at -2 where it crossed. The other thing we need to know when we are, tangent. The other thing we need to know when we're graphing the tangent function is we have to know about the asymptotes. And in order to account for the asymptotes, in order to graph it, it's going to be the left asymptote, which is -pi/2, is greater than, because it's on the right, greater than bx minus c, which is less than pi/2. Sorry, -pi/2 is less than bx minus c, which is less than pi/2. This takes into account the two asymptotes. And this will give me my two asymptotes. My 0 is going to be the point that's in between the two of them. And then I have my quarter point and my 3/4 point, which is in between the left asymptote and the 0 and the right asymptote and the 0. So if I have for instance, y equals 3 tangent of 2x. Y equals 3 tangent of 2x, and they expect us to graph this. Well, the first thing we need to know is our amplitude. And our amplitude is the absolute value of 3, which is 3. Absolute value of 3, which is 3. I will draw it right here on the board. That means that at 3 and -3 is our amplitudes. Now we have what? The equation itself, -pi/2 is less than, in this case, 2x, which is less than pi/2. We want to get x by itself, so we would what? Divide by 2. So if we divide by 2, that's -pi/4. 2 times 2 is less than x, which is less than pi/4. Okay, divide by 2 there also. So now, instead of our asymptotes being -pi/2 and pi/2, our asymptotes are going to be -pi/4 and pi/4. So we would start at -pi/4, pi/4. That's my asymptotes, so that's where we would have our dotted lines. Halfway in between would be my 0, since both of these are the same. The origin is my 0. And it goes up from left to right, so we would have our quarter point, which would be -pi/8. It's the average of the two. And we have pi/8, which would be my 3/4 point. So it would start from going up, so that would be my quarter point at the bottom amplitude, and the 3/4 point being the top amplitude, and we would then draw the line connecting them up. And this would be taking care of itself with the period being longer or shorter. That is the equation, in order to look at the asymptotes and to graph. Okay, suppose we have to look at the cotangent. The cotangent. How would the cotangent be different than the tangent? Well, looking at the unit circle, we would see that it is very similar in that it does the same thing. It has asymptotes, but we have to look at where the asymptotes are at. So if I have the standard y equals cotangent of x, y equals cotangent of x, cotangent is the x over the y. So here at 0, x over y would be 1 over 0, which is undefined. So the cotangent would be undefined at 0, which means we would have an asymptote at 0. And as we go up at pi over 2, x over y, 0 over 1 would be 0. So at pi over 2, we would be at 0. And then as we keep on going around, at pi, it would be again x over y, which would be undefined. So at pi, we would have the second asymptote, which would be undefined. So for the cotangent, at 0, the answer would be 0. At pi over 2, at 0, the answer would be undefined. At pi over 2, the answer would be 0. And at pi, the answer would be undefined again. So instead of its asymptotes being at negative pi over 2 and pi over 2, the asymptotes would be at 0 and pi. Still, the period is going to be pi units. And still, we have a quarter point and a 3/4 point. My quarter point is going to be halfway between, which is going to be pi over 4. And my 3/4 point is going to be halfway in between, is 3 pi over 4. My amplitude would be 1, so I've got 1 and negative 1, just like before. But at pi over 4, if I look at it, we have what? Square root of 2 over 2 over square root of 2 over 2, which is 1. So that would be my upper amplitude. And at 3 pi over 4, we'd have what? Square root of 2 over 2, square root of 2 over 2. But the x value is negative, so that would make it negative 1. So at the 3/4 point, it would be negative 1. So unlike tangent, which rises from left to right, the cotangent falls from left to right. The cotangent falls from left to right. And unlike the tangent, which has the asymptotes at negative pi over 2 and pi over 2 is less than bx minus c, the cotangent, amplitude being the same, absolute value of a, but the asymptotes would be 0 is less than bx minus c, which is less than pi. So when we're trying to graph that one, if I come right here and we look at one, suppose we have y equals 2 cotangent of 2x minus pi over 4. In this case, that's about all the things we can have. We got our amplitude, which is 2. We have our asymptotes, again, cotangent, so we're using this one, which is going to be 0 is less than 2x minus pi over 4, which is less than pi. And now we would what? Isolate the x so that we can see where our asymptotes are at. So the first thing I'm going to do is add pi over 4 to both sides. So if I add pi over 4, I got pi over 4 is less than 2x, which is less than 5 pi over 4. And now if I what? Divide by 2, that's going to be pi over 8 is less than x, which is less than 5 pi over 8. So here would be my asymptotes. My amplitude would be 2. All I have to do now is put them in and find my 0, my quarter point, and my 3/4 point. So at pi over 8, that would be my left amplitude, my asymptote. At 5 pi over 8, that would be my right asymptote. But just looking at it, can we tell what the middle point is? If you can't tell what the middle point is, you take the average of the two and it gives us the middle point, which is our 0. So we have what? Pi over 8 plus 5 pi over 8 over 2. Which would give me what? 6 pi over 8 over 2. Take it, flip it, and multiply, and we'd have what? 6 pi over 16. And 6 pi over 16 would be what? 3 pi over 8, if we simplified it. So this becomes 3 pi over 8. This would be my 0 point. Now we want to find our quarter point and our 3/4 point. The quarter point would be the average of these two. Again, we can do the same thing, or we can see that this is 1/8, this is 3/8, so this must be 2/8, which is what? Pi over 4. Since this is 3/8, this is 5/8, this must be 4/8, which is pi over 2. And since it is now, oh, by the way, we have what? Our amplitudes, which goes up to 2 and down to -2. And since it is our cotangent, we know that it what? It falls from left to right. So therefore, the upper amplitude is my quarter point and the lower amplitude is my 3/4 point. And we draw the line. That would be the tangent and the cotangent. The differences are rises from left to right, falls from left to right, and the difference would be the asymptotes for the tangent is -pi over 2 and pi over 2, and the asymptotes for cotangent is 0 and pi. And that concludes the tangent and cotangent. But we do have two others. We have the secant and the cosecant. So if you know how to do the sine and the cosine, then you know how to do the secant and cosecant because they're the same thing. The amplitude, the points of interest, the period, all stuff are the same. The only difference is that they're inverses of each other, so that the cosecant is the inverse of the sine, and that the secant is the inverse of the cosine. So when looking at that, if I have to graph the function y equals cosecant of x, if I'm trying to graph y equals cosecant of x, we can put all the stuff on it, the a, the b, the c, we can put all that on it, but right now we're just trying to find the basic. So if I'm trying to find y equals cosecant of x, instead I'm going to find y equals the sine of x, which in this case we know. Sine of x, we got what? 0, 1, -1. At pi over 2, we come up with a maximum point. At pi, we come back to a 0. At 3 pi over 2, we come down to a minimum point. And then at 2 pi, we're back to a 0. And normally, this is what we do. We would graph the sine curve. And that's what we're going to do. We're going to graph the sine curve, but instead, I'm just going to make it an imaginary sine curve. So I'm going to make a dotted line, because this is the sine, but we're looking to do the cosecant. How does it differ? Well, it differs here. These are zeros for sine. But if I do the inverse and flip it, instead of being 0, it becomes 1 over 0, because we're inverting it. And 1 over 0 is an asymptote. It's undefined. So this becomes an asymptote at all of my zeros. They become asymptotes. And now, instead of having this, which is the sine curve, these upper limits or amplitudes becomes vertexes of parabolas. So the actual cosecant is going to be the parabola facing up from the peak or the top amplitude, and a parabola facing down for the lower amplitude. Everything we do from phase shifting to period, all we do is do that with the sine. Once we graph the imaginary sine curve and then put the zeros as asymptotes, we then just draw the two parabolas, which makes the cosecant graph. For the secant, we do the same thing. Y equals secant of x. We're going to graph the y equals cosine of x. We're going to graph the y equals cosine of x. So if we look at the y equals cosine, we know that these points would be the same. 0, pi over 2, pi, 3 pi over 2, and 2 pi. We also know that what? Our amplitude would be 1, so that's 1 and negative 1, but the cosine starts at a max, then goes to a 0, then down to a min, back to a 0, and then to a max. But instead of graphing the cosine curve, we're going to do a dotted line of an imaginary cosine curve. And just like with the cosecant, where the zeros are asymptotes, with the secant, we look at the cosine, and the zeros are also asymptotes. The zeros would be asymptotes. And just like in the cosecant, where we have the top and bottom amplitudes, we draw parabolas. Well, since we only have half here, we draw a half of a parabola going up. We draw a half of a parabola going up. And here, where we have our lower bounds, we have our parabola facing down. So the cosecant and the secant are obviously easy. All we have to do is know how to graph the sine and cosine curve, which we learned in section 1.5. And the tangent and cotangent, we're finding our asymptotes and then putting our middle point as our 0, and then our quarter and 3/4 point, and either going up if we're tangent because it's a positive slope, or down if it's cotangent because it is a negative slope. And that is graphing of the trig functions. I will see you at the next one.